Have you ever wondered what happens when you type in your password? It's more than just taking what you typed and comparing it to the same thing stored in a file. Instead, it involves complex, one-way mathematical functions. If your password was stored in plain text, hackers who broke in could take the password file and steal everyone's passwords. Luckily, we have math to protect them. One method is called symmetric key encryption. Symmetric key encryption takes your password and a secret key and produces an output. The problem with using symmetric key encryption, though, is that it's reversible. The same key that allows you to encrypt the password allows you to decrypt the password, meaning if the hacker got the key, he has the passwords. Storing passwords requires a much more complex process, one that can't be reversed. That's where hashing comes in. Hashing is a mathematical function that takes any input, a letter, a sentence, an entire book, or even this video, and produces a fixed length string of unrecognizable letters and numbers. What makes hashing useful is it can compute almost instantly in one direction, but is practically impossible to reverse. Even the smallest change in input, like changing a single bit of data, will give you a completely different output. This is known as the avalanche effect, and because of it, you can't go from output to input. The only way to find the original input is a computationally heavy process known as brute forcing. Brute forcing involves computing billions and trillions of inputs until one happens to produce the desired output. But hackers already have huge dictionaries of previously computed inputs, which makes common passwords very easy to find the outputs for. So to make things more secure, passwords are often salted. Salting involves taking a random assortment of numbers and letters and adding them to the input before hashing. This makes pre-computed dictionaries of regular passwords useless and makes brute forcing even harder. And that's how math protects you from hackers.